Hi everyone, this is Mrs. GA, and today we are going to be graphing piecewise functions. So I want to do just a quick review of some basic functions that we'll be working with today, just so you can see what they look like. So the first one would be a constant function. So a constant function looks something like this. So it would be like y equals -2. A constant function is essentially just a horizontal line at your given y value. So this is what a constant function looks like. A linear function, hopefully you guys remember the most basic form, y equals mx plus b. So that would be something like y equals 2x. So my y-intercept is at 0, my slope is 2 over 1, and we should always get a straight line. All right, the next one we're going to talk about is quadratic functions. So there's two ways that you might see a quadratic function written. So one is ax squared plus bx plus c. And then one would be y equals a times x minus h squared plus k, or some form of this. So here you would need to know the vertex formula to find the vertex of this parabola. Here our vertex is always going to be hk. And then the most basic shape of our parent function, y equals x squared, is of course a parabola. So it looks like this. There you go. And if our lead coefficient, if our a value is positive, we open upward. If our a value is negative, we open downward. Now let's look at that absolute value function. So remember, absolute value functions make a V-shaped graph. A very common form of the equation would look something like this. And you can use this h and k to help you find the vertex of your absolute value graph. So let's graph just the parent function, y equals absolute value of x. This one would have a vertex at 0, 0, and it's kind of like a linear equation going to the left and right, which is opposite slopes. And there you have it. So these are the four basic functions that we'll see today within our piecewise functions. So a piecewise function is a function that is split up into different intervals, and each interval is defined by a new or different function. So a few tips for graphing these. You are going to want to evaluate both pieces of your function at any transition point. So any change in interval, you are going to want to evaluate both functions, whether they're defined or not, and then you just are going to be really careful about whether you use an open or a closed point. But you will want to evaluate both interval or both pieces at any transition point. And then from there, you can complete the graphs on the remaining intervals, either by making a t-chart. You can use transformations or just any shortcuts you have for graphing. I think the biggest thing is just to watch out for those transition points and make sure you do have something for both pieces of the function. Okay, so let's try this one together. So for those transition points that I was talking about, you can see in this example, there will be a transition at -2 and a transition at +2. So here we have 3 different intervals. So let's start with this first one. This is a constant function. So this says that f of x is -2 for any x value that is less than -2. I'm still going to evaluate this function at -2. I'm just going to make sure to put an open circle. So when x is -2, y would be -2, but again, an open circle. And then I just do a constant function to the left because it's for all x values less than -2. So now I'm going to jump up to this next interval. I can see I have a linear equation. So I am going to start by evaluating it at -2. So if I substitute -2 here, we get +2 plus 1, which is 3. And here I will do a closed circle. And then we know that in a linear function, the coefficient of x is always our slope. So this is this function has a slope of -1. So I can continue that until I hit +2 for my x value because that's where this interval stops. It's also a closed circle because it's included there. And there's this section of my graph. Okay, let's move on to that last section of our graph, another constant function. So I am going to evaluate it at 2. So when x is 2, y is 1, except I'll have an open circle there because it's not defined at 2. And then everything greater than 2, it's just a constant function, y equals 1. And there you have it. Okay, let's try one more together. So here I can see I just have 2 intervals. My transition point is going to be at 2. And everything to the left of 2, I can see that I have this quadratic function. So let's start with this. I am going to evaluate it at 2, but again, I'm going to use an open circle. So if I substitute x equals 2, I have 4 minus 4, which is 0. So when x equals 2, y equals 0. And again, I'm going to put an open circle there like this. Now from here, I can either make a t-chart, I can plug in x equals 1, and then I get -3. I know that my vertex here will be at 0, -4, and then I can reflect that going forward. And here's my quadratic function. And again, you should have that open circle when x is 2. Now, let's do the bottom part of our piecewise. We have a linear equation. So I'm always going to start by evaluating it at 2. This one will be a closed circle. So if I evaluate this one at 2, I get 2 minus 2, which is 0. So here, I actually have a closed circle at 0. So even though it wasn't defined in the other one, since it's defined here, I can fill it in with a closed circle. And then this is just a linear function with a slope of 1. So I can just continue it to the right with that positive slope. And there you go. Okay, we do have one last example that we're going to try together. So again, here we have 3 different intervals. I see that we have an absolute value interval, a quadratic, and a linear. So let's start with this absolute value piece right here. So I'm going to start by evaluating it at -1. Again, even though it's not defined there, I will want to substitute -1 and then put an open circle. So if I have -1 plus 3, I get 2. Absolute value of 2 is 2, times -1 is -2, plus 2 is 0. So when x is -1, y is 0. So I'm going to put an open circle there because, again, it is not defined here. So for this, for the rest of the graph, you could just substitute points, or we can remember that our vertex of this is going to be at -3, 2. So I can plot that point. And this absolute value function is going to open downward, and it's going to the right, it will have a slope of -1. So it'll actually look like this. And then to the left, it has the opposite slope of +1. So again, +1 if you read the graph from left to right. So our function looks like this on this interval. So now we can move on to the quadratic portion of our interval. Okay, so of course we're going to start by substituting at our transition point. So at -1. So substitute it here. -1 squared is +1 times -1 is -1 plus 4 is 3. So at -1, our y value is 3, and it will be a closed circle. This one, we can, again, substitute more points, or I can see that this function has a vertex at 0, 4. Then I'm going to reflect this point, and I can plug in a few additional points when x is 2, y is 0, and when x is 3, y is -5, because I want to continue this interval all the way until x equals 3. So I'm going to do this. And now I'm going to move on to my last interval, which is a linear function. So I'm going to start by evaluating it at 3, even though it's not defined at 3. So if I substitute 3, I get 2/3 times 3, which is 2. So I'll do an open circle at 3, 2. And then I can see that this linear function has a slope of 2 over 3. So I can go up to right 3, goes a little bit off my graph, and it would go like this, and it would continue on infinitely in the positive direction. So this is our last example. Just remember, when you are graphing a piecewise function, be sure to evaluate both functions at any transition point. Even if they're not defined at that point, you need to continue your graph all the way up until there. So you'll evaluate them both, and then just be careful about which graph you use an open circle and which graph you use a closed circle. All right, that's all for today. Thank you so much for watching.